to record. All right, so that's basically sort of the whip through of the settings and things that we might know. And if you need any additional type of practice on a couple of things here, there's a real nice little, and it's small, and this putting it all together workflow, where basically you're starting with a drawing that has some points in it, and that's all that you have, and you're using that. It's a stockpile. You're going to model the stockpile, do a little borrow pit out of the stockpile, do the adjustments and that sort of type of work, and a little haul road that comes into the stockpile area. So it's a nice little exercise that doesn't get too huge. They help you sort of put a lot of those fundamental concepts together. But we're going to jump into the civil part of things and talk about the civil tools and the design. And we'll be using a lot of these fundamental tools like the 3D viewers and all those different things as we go along. So here's a couple of things. We're starting on page 58 in the manual. And you may notice also that the format of the class, I'm not one of these turn to this page and let's read this section together class type of instructors. This is material for your reference. We'll use it for some guidance, but we're not going to sit down and just read through everything word for word. So this basically talks about, in this first part, this single roadway design. And Carlson has two approaches to roadway design. One is just a single alignment and profile, and that would be what they call road processing, or they have this concept called road net. And it basically takes all of those same individual pieces that you would do with each individual road, and it puts it all together into this network of intersecting roads, potentially intersecting roads. They don't all have to intersect, but it's just a collective effort. So if you think of like all the roads in a subdivision, that would be best handled using RoadNet technology. Doesn't have to be, you could do it individually, but you'd have to keep track of the edits, whereas RoadNet will help do that for you. Okay. So what are some of the things that we need in a simple roadway, of course, is we're going to look at some of these different stuff, these design templates and the process road design to tie all this stuff together, and then some grading tools that we're going to cover later as well, like ponds and building pads and such. And then we'll look at road network as the final round of the class. So the basically roadway design is handled in two potentially different fashions, just generically. One is that if you think about a roadway, let's say the access road, the driveway into a site, like an industrial site or something like that. So if you think of designing that roadway from the perspective of, say, a site development or site design engineer, well, the site guys might consider constructing this site, and they think about constructing, like down at the subgrade excavated area, and then they got a certain thickness of a certain materials, and they will build the site up till they reach the top surface. So it's basically a vertical design approach. But then they have to have all of the edges of that roadway structure generated by some means, from the surface down, so it can reflect where this goes. Now, from a roadway designer's perspective, we don't do it from the bottom up, we do it along the length. We are alignment based, and we're going to say, well, based on this cross-sectional shape that I'm going to define with my template, I want you to take that template and I want you to run it down this alignment and follow the left and right curves of the alignment and follow the up and down curves of the profile and apply, like what you see here on the next page of the manual says, apply, all of this information to that and do it every 50 feet, every 10 feet, every 25 feet, whatever your station drop interval is. And so that makes the road design horizontal instead of vertical. And if you are going to add up the materials, for instance, that are going to be needed for that road design, the computer is going to do what's called, and what we used to do manually, what they call the average end area method, is that it drops that template at one particular spot along the alignment, and then it reads all of the areas of this information. And sometimes you'll have the existing ground, compared with the design ground and that sort of thing. And then it goes to the next station interval, let's say 25 feet away, and drops that template down again. But now you've got different amounts because the existing ground is going to be different at that particular location. So to compute the volume between those two 25-foot separated slices, it's going to look at the areas of each end of that section. There's your end area. And it's going to take the average of them because the assumption is that the road changes linearly, not literally, but linearly. It changes between station drops. So if I've got, 10 yards of stone at this, or 10 yards of, let's say 10 yards of cut. Let's just talk about cut and fill. So if I've got 10 yards of cut in this location, but I go 25 feet away and I've only got 5 yards of cut, but I've got 5 yards of fill that I have to come up with, then on the average, I've got 7.5 layers of cut, across that 25-foot distance. Okay, or if I did that mental math correct. I'm not here to see how mentally agile I can be, but anyway, you get the concept. So that's called the average end area method. And so that is going to be pushed through our site horizontally, whereas a typical site design approach would be to design it from the bottom up. And you might have, you draw the closed outlines of the edge of the pavement, and you'd say, okay, yeah, so this is my area, and inside that area I've got so much, stone and asphalt or concrete and sand, all the different things that make up that outlined area. Okay, but we're going to be looking at our road design approach from the average end area method, the way that most highway designers would do it. So the next part, so here's their, let's see, what does it tell us about our Carlson Civil's 3D design approach? So, so we need that, like I said, we're going to have a couple of things, and here are the things that we need to have. You've got to have a center line or that horizontal alignment. And then you need to tell the computer, how does that roadway that follows those turns horizontally, how does it behave up and down? And that's your profile or the vertical alignment. And then you design a cross-sectional shape. That's their template that you're going to push along that alignment. Then you process them, and out it comes into our work. Now, down here, and it says in our book, optionally, you should start with a surface design that defines the existing ground, so that it can also tie in these side slopes. whether it's cut or fill or benched or different slopes based on different conditions, okay? So those are called end conditions or, cut and fill slopes. So we would have those um, as an optional part of our design work. You can do it just what they call backbone only. So it only goes out to the edge, the outer edge before it goes cut and fill. But that's usually what we're interested in, is seeing all that total cut and fill. All right. So we're going to take a look at that particular process of building a particular file. So we're going to go and we're going to open a file in your data set called roadway design base, and we'll make a new coordinate file to go along with it. Okay, we'll call it roadway 01. So let's go and do that. I'm going to go ahead and close this file off. And I'm going to open, and I'm going to look in my data sets for civil class. Here I am. And I'm going to look for roadway design base right there. And when you get yours up, it should look something like this. Whether the colors are the same or not I don't know. But this basically, if we look at it, can be understood or interpreted as being a contour map, which it is. And I even see some of these depression area contours where I've got a indentation, little ticks that indicate that it goes down and not up. And I see I've got this alignment that starts in one end, and it goes through a couple of PIs and it goes down to this end. Now there's no curves in there. I mean, it doesn't even necessarily have to be a roadway alignment. That could be, say, the alignment of a sewer line. I've got manholes at those bend points, so they're not going to have curves in them at all. But in this case, this is what I'm starting with, and I need to design a road to work with this. All right. So what again are the things that we need? We need an alignment, we need a profile, we need a template, and we also could use a surface. Now, what do we have here surface wise? If you've looked at this file, let's let's click on it once. And it all gets selected. It didn't let me pick one of the contour lines. And look at that over here on my properties, and I see that it is an AECC database surface 10. So that means it came from the AECC DB type of data structures is what Civil 3D uses. So that tells me it's a Civil 3D surface object. And there's several other things that you can use to get at the data that's in here. Because if you're familiar with Civil 3D and to be fair to other software also does this, it creates surfaces, but it keeps them as part of the drawing file itself. It's an embedded, what they call an extended entity. But Carlson, on the other hand, and in contrast to that, and it's a conscious choice, they store their information externally to the DWG file. So I can take whatever my DWG file winds up doing and showing me all this wonderful stuff about a surface and points and roadways and whatever. I could send it to anybody who's got AutoCAD, even AutoCAD LT, just something that somebody else wants, and they can load it up and look at it and use my drawing. It doesn't have those, what they call, extended entity objects. So that again was Carlson's approach, was to keep it as separate data files, represented, created in the drawing so that it looks like that to you, but it's still, a center line alignment in one of our projects is still just a polyline. Now it's a polyline that has extra things attached to it that make it behave like a center line. But at the end of the day, it's just the polyline. If I give that file to somebody else who doesn't have Carlson or any other thing, when they select it and look at its properties, it'll tell them, hey, this is a polyline. It will never say, This is an AECC-DB alignment, okay, because that's just not the way Carlson stores the data. All right, so now a couple of other clues here. The first clue again is that it looked like when I selected this, that it was complete, it all highlighted. That looks like little dash lines there now. It highlighted as a unit. Okay, so it behaves not only because, and I look at my properties and I see that it is a tin surface, a triangulated irregular network tin surface, but it not only did, um, not only shows up as that, but from the perspective of an AutoCAD user that may not be familiar with that kind of stuff, when that whole thing lights up, we can, we do have some experience that says that could be, either an external reference file, and I see in my properties it's not an external reference, but it could be treated like it's a block. And in fact, you could explode this object. And if you do that, it's going to explode it into the next level down, which would be a block from there, and then explode that again. And it explodes it back out into the resulting polylines that you see for these contours being drawn. However, these drawn contours are not actually just drawn contours here because it's part of a Civil 3D object, that Civil 3D surface. It's representing itself as drawn contours because I'm looking at it in plan view. Now we're going to look at it here in a second in perspective view, and you'll see it change. And that's another clue. Now, all this is going to lead up to the fact that Carlson has import and conversion routines to handle data from other projects, and particularly Civil 3D. But let's take a look further at what this might be. So I look at that and I say, well, it's, I'll hit escape and unselect it. If I hover over it and choose it again, it tells me what it is. But let's look at this in 3D. We're going to change our perspective. Now you can either use the little cube over here, maybe get that corner that right here below top. So I'm looking at the top left corner. And when I do that, or I can hold the shift key and press and hold the wheel on the mouse and just move it around. And so now you can see there's my alignment that was done down here at the bottom. And what do I see about that surface now that used to look like contours? Well, now it looks like triangles. Well, that's the way Civil 3D handles surface entities. You tell it how you want the surface to be displayed in these different conditions. One's in plan view, one's in profile view, and one's in what they call model view or three-dimensional um, perspective view of the object. And excuse me, and by default, it is set to, when I go back to plan view, and I'll go up here to this cube and hit top, see how it switches back? Because that's my plan view representation. If I press and hold the shift key and then press and hold the wheel on the mouse like a button and then push it around. Now watch what happens when I let go of it first. Now, did you see a minute ago there, you saw those little long yellow skirts. Now this is before I let go of the button now. You see those long yellow skirts? That's another thing that Civil 3D does, is typically put what they call data skirts on these objects. But now as soon as I let go of the mouse, it switches to displaying all these triangles. And those of you who might be new or recently in the terrain modeling world, terrains are typically represented by all of these triangles that line up edge to edge and form this contiguous blanket of material based on these little triangles that again match edge to edge to edge. And they're all triangular because a triangle represents the minimum number of points that you need to define a plane or a planar region in space. Three-dimensional space, it takes at least 3 points. So each one of those planes has its own orientation within the context of these others, and when they lie adjacent to one another, then that forms the surface along which you can, do your design work or uh, compute quantities between this surface and another surface, because you just measure the differences and sum them up over the area that you're interested in. Okay, now, if you see my triangles here look like a wireframe, I'm going to go right here to this little this little ghosted area here where it says the custom view, and I'm going to click that little 2D perspective. I'm going to change that, or you could go to the view menu and you could choose probably view manager. Let me see if that's what I'm looking for. Yes, go to the view menu, view manager, and then pull this down. You can choose from this visual style. Okay, so either way. So I'm just going to come here and I'm going to change that to conceptual. And if you change it to hidden, well, then it's no different from the wireframe. Uh, Realistic versus conceptual. So if I had materials assigned to that, you would see those materials show up. And I can also, now as I move this thing around, you say, well, that looks, I'm seeing the reflection of the sun or whatever light source. And I say, well, that looks very much like, uh, some kind of terrain. Now, this also looks like, I'm going to go back now and set this back to, um, you set it back to wireframe, so that when I go back to top, or let me see, if I keep that as realistic and then hit top, you see, I'm there, but I'm still in, you see now my skirts are looking solid. So I'm still in this different viewport. So if I go back to wireframe, that's my basic normal CAD way of doing it. So now, how do we get that surface information available to us? Any thoughts, any ideas? What are what would we normally do? If we were given this as a drawing, let's say they were just drawn polylines, they weren't this special object. What we typically do would be, create a surface, call it existing ground, for instance, and wherever we get the data that defines that existing ground, in this case, all we have are contours, right? So that would be, we let the computer walk its way around each of these contours and sit on each one of those vertices and each contour line, look around itself 360 degrees and start forming triangles between that vertex and the vertex of the next line it finds sitting away from it. So if I were to look right in here, for instance, at this area here, and if I were to let's turn it up just a little bit, now you see those triangles have formed. You can see the shape of the original outline is, follow my mouse here, and it has connected back. It sits here and sees that point, and then it looks around and finds points on these other contour lines and starts connecting up triangles between each of those sets of those pairs of points. Okay, so that gets into our the concept of using break lines and that sort of stuff. Now, Patrick, let me ask you as well. Sarah and Scott have been through um, a fairly immersed treatment of break lines and such, and I imagine you probably got a good understanding of those. Or how are you on surface modeling in general? Are you comfortable with that? Uh, or
Uh,
or would you
I
like?
could be better at brake lines. I
Okay,
mean,
all right.
sometimes my brake lines the triangulations come off screwy
Ye-
when I've tried them. Used to, did them a lot more, and I was a
Yeah.
little bit better with them. And if
Okay.
I'm trying to basically do cross sections under a bridge,
Yeah.
trying to get all those different layers of elevations because you're at road level, but you're also underneath, and getting that to all
Right.
kind of match up kind of gets a little screwy sometimes.
Yeah. Okay. So what, and the reason I ask that is that, and we have some time to do this in the class, and I think we will, but we're going to get a, a little short introductory, we'll sort of wind the clock back to an introductory type of approach on modeling surfaces so that you should then at that point be very comfortable with break lines, how to make them, how to make them work for you and when and where you need them. So we'll do that. I'm glad I asked because I didn't want to first of all, bore you and waste your time if you're really comfortable with it, but if it's something that you could benefit from knowing more about, then let's take that opportunity. So, but while we're still in this drawing here, before we get to that, I see I've got something here. Now, the way that I can work with this, if the way I can extract this out and get this into surface data, I've got two approaches. I can do, I'll go back to plan view here. Let's see here, plan. There we go. So I can explode this thing, and it takes me a couple of times. If I explode it once, this thing called an AECCDB 10 surface would explode into a block because AutoCAD or Civil 3D at the time when that surface was created, it created the block of all of these, in this case, drawn contour lines. It also created another block of all of those rotated triangles. Okay, and so it just stores those block definitions and it brings them forward depending on which view perspective you're using. Okay, so I, as a Carlson user, though, without having access to Civil 3D, would need to explode this object into a block. And in that case, if I exploded that block, it would contain these contour lines. If I exploded this, and even if, whether I'm looking at it with shading on or not, uh, let's go back to the wireframe. So if I explode this one, then that's the other block that gets exploded. Okay, and then if I explode that block further, because it explodes this object, a proprietary object, a Civil 3D object, it explodes that into a block. If I explode it again, it explodes the block into its component pieces. In this case, it would be a bunch of lines that draw it as a triangle. If I were to explode that block here, then that block would be the drawn polylines. And then explode that block, and it takes that resulting block and makes it into its each individual pieces. So each one of those little pieces of lines that make up the contour lines would be, it basically takes it down to its simplest level, at which point you could use that to define your surface, et cetera, et cetera. However, we have an even more interesting way of doing this, and, or not more interesting, but a little more automatic, let's say, is instead of us having to control all of that information, when I select this and I see in my properties over here on the left that that is an AECCDB Surface 10, that immediately tells me, oh, that's Civil 3D. Okay. Now, even if you do see one that has a Civil 3D data object, whether that's a coordinate or a parcel or a sewer pipe or an alignment or a surface, the version levels may not necessarily line up. You might have to go to the Autodesk website and download an object enabler and all that kind of stuff. However, in general, um, you're going to have these tools available, and that Carlson recognizes its origin and will prepare things for us in our particular um, world. Okay, so let's look at the file menu real quick, and we're going to look down here about midway down. There is an import command that's a pull right. So I'll take that and go to the right. And here you can import all kinds of different things we suspect, and therefore we'll try to see that that is a Civil 3D drawing because I saw that AECCDB surface. So I could go here and then just pick a surface, or I could have labels, pipes, line work, center lines, points, or even all Civil 3D objects. So let's just choose that one. And it's going to read that file, and it's going to create them for us. So the first thing it's going to do as it's looking for Civil 3D data is it's going to look for points. So it asked me for up, and always read this top stripe. It tells me what's the coordinate file you want to process. Now we're going to, if you notice, when I open up this file, see at the grayed out part of the top stripe, it says my CRD file set to none. But we talked about over here, we were going to set a coordinate file to roadway 01. So let's do that. So we'll call this, now I'm going to switch to the new tab, make sure I'm in my right folder, and I'm going to call this roadway 01. Is that what I said? No, we call it roadway 01. Yep. So roadway 01. Now, I noticed down here, it's actually showing up in my list of files, but because I'm on the new tab, it's going to try to create it new. So if I say open, it says up, it already exists. You want to replace it? Yep, I do. So I just cleared the decks. Now, so for a more complete conversion of Autodesk custom objects, we recommend saving the drawing first to update the objects to the latest version. Well, we can do that. It won't have any effect, but all we're doing is just saving it. And it then goes into the command. And you see it ran through the series of searches to try to find data. And now it comes back and says, I found a surface called Phase 6 Original Ground. You want to create a Carlson 10 surface? I'll say, absolutely. I'll say yes or yes to all if I had multiples. And so now here I'm in I'm going to just keep the same file name, Phase 6 Original. Hit save, and yes, that's also pre-exists. That's for people who might have problems doing the conversion. So I'm just say yes, overwrite it, and it now has overwritten the surface. Now, what else has happened when it does that? Click on one of your contour lines now. And now you see it has basically exploded that AECCDB surface 10 into its block, and then exploded that block into its components, in this case, drawn contour lines. I've not ever tried this, but now if I shift, roll up here, I'm not going to get those triangles displayed because these again are just, if you look at my properties, they're just polylines. These things down here, let me change this back to a realistic view. You see how those are solid, these parts of that skirt. So if I put that back in my wireframe, if I select one of those, I see that it is a 3D face. That's a standard CAD entity, just a three-dimensional face object. Okay, so all of those lie basically in their own vertical plane, edge to edge, created all the way around it. Okay. So now I've got these, and I don't need these skirts on here. I want to get rid of all of those. So if I just select one of them, I'll right click and choose select similar. Now you see it's found 858 3D faces, and now I'll just delete those. So they're now gone. And if I look at this, I select that boundary. That is a 3D polyline. Okay, so it's already been, it's already wrapped itself around that, all this data. Now notice right in here, you see these little bump points like that right in here, and then there's some right in here. But these contours are out here. Now, what does that tell us? Not that we ever need to really dig into it this deeply, but what that means is that if I were to just explode this drawing out and select all of these polylines to be the source of my data modeling, then I would not see that little, see how this line comes up and rides that, think of that as sort of like a little ridge. You can see it, let me go back. Where was that? Right in here. Yeah, so you see right in there, you see how that's sort of like a little ridge across the top, but there's nothing, there's no line work out here in the drawing that would have formed those bumps. So my understanding is of what's gone on with that is that the surface model was created with things more than just these lines, and then this boundary was placed on it just as part of that process. So we got some useful things we can do with it. We have successfully extracted a surface file called phase 6, original ground. We have this polyline. If I look at that polyline, I've got this 3D polyline. It's on a layer called C-topo-BNDY. So my C, which stands for civil, and they usually might propose types of layers, but C boundary. So it's my civil boundary, civil topo boundary. So you see all these layers that are pre-built. And that's part of, it can either be part of your drawing template, or in this case, it was part of our drawing that we got from somebody else. All right, so now we've pulled out this surface and we're left with drawn contours. I've got a contour here that's on a layer called C-topo MAJR. So my topo major, topo minor, and I've also got a couple of those little depression area, like right in here. This is on C-topo minor, and these are little depression ticks that are on C-topo minor also. So now we've lost the effect of those being on, or being a particular depression indicator. It still will be depressed in our surface model that we've created and converted. But if I were to use this data, there's no difference between that contour line and another minor contour line. It's just these little visual indicators that says, hey, this is a depression contour, meaning it goes downhill instead of uphill within that area. Okay. So, you could actually take those little ticks and get rid of them if you wanted. Okay. So now the whole thing behind Carlson making that as a surface file, let's say something happens to your drawing, or you don't have a drawing at all, but you do have that surface file, is that I can recreate this entire drawing just from that surface file that I created. Now, there's a couple things you might want to know about it. I look at this and I'm going to select this index contour. That's my C topo major. I'm going to look down here and read its elevation. It's an elevation of 100. Okay. I'm going to press escape and I'm going to get the next one adjacent to it. So this one here is on C topo minor and it's on an elevation of 95. So there's a 5 foot difference in elevation between those contours. Now this would be a very steep terrain if I were to actually have something like that. I would expect this to have been created more like a 2D or sorry, a 2 foot contour interval. But anyway, here's our contours. We know what the contour interval is. So even if I erased all of those um, contour lines, in fact, let's go ahead and do that. Let's go to File or Edit rather, and let's erase and erase by layer. That's also on my layers toolbar. And I'm going to select from the screen and I'm just going to draw a little crossing window left or right to left and pick up one of the index, one of the intermediates, then hit enter. See it identified the layers and I'll say okay. And now they are completely gone. And, oh no, where's my surface? Well, your surface is safely in that file that we saved when we did the import of the Civil 3D data. And so we can get that back. Let me switch to my Civil module just so we're all on the same page here. So if I'm in Civil and I want to recreate those contours, I'm going to go to my surface menu, which is right here past the 3D data menu. And I'm going to choose contour from a tin file. That's triangulated irregular network. So there's my tin file. And the file I want to use down here's the one that I was just recently there. That's mine. Or I've got, these different uh, tin files within my data set. I wonder what that is. Zip road merge. Well, it doesn't matter. I'm going to use my phase 6 original ground. And I'm going to open that. So it's going to read that and it has everything it needs to be able to recreate the contours that we either purposely or accidentally got rid of in our drawing. And this command that pops up is it's the very same command that you get when you're trying to create a surface, only we're going to be focusing on these contour and label tabs next. And the command we're not going to, or the triangulate tab, we're not going to worry so much about. It also is missing the filter tab that lets you filter out things that you used to create with. So it doesn't apply here, so it's filtered out. So the one thing on the triangulate tab that you might want to do is this ignore zero doesn't even matter. It doesn't matter if that's on or off. And this erase previous contour entities. So if you had some other contours that you had drawn and had done them with a Carlson command, if you have that says erase previous contour entities, and it's not just contours, it's also triangles and boundaries. But if you said all, if that was set to all, let's say we got another little, parking lot or a site design somewhere and we drawn the contours for it. And if we say all and we hit the OK button here, it's going to erase those. Now we could recreate them just like this, or better yet, let's just turn it off right now. So I don't need to worry about any of this kind of stuff at this point. So let's go to the contour tab. Now, if you remember, there were specific layers and a specific interval that we had set. And right now, what is stored here is what was last used when I ran the command, and that was C-surf-cntr-minr and majr. So that's just a variation on the same thing we saw before. And in which case, those layers don't exist in this drawing yet, but because I have them identified here by name, it will create them for you. But let's choose select and let's see if we can find it. Well, that one started with a C. dash topo, was it? C dash topo. I'll just start, I'm sorry, not there, up here in the filter, C dash topo. So there's now my C topo, and oh, there's major and minor. All right, so it's asking me for the contour layer, which is the minors. So I'm looking for C contour minor, right there it is. And I'll say okay. And down here now, if you turn this checkbox to draw the index contours on, now I'm going to do the same thing with my C dash topo and look for major. Well, there it is. Now what else do I have in there? So I'll say, okay. All right, so now I'm going to draw those, but look at this, my contour interval. Remember I looked at them before and I had a 5-foot interval. If I want to recreate those exactly, I would turn this from 1 to 5, in which case it would be every 5 feet. You get a contour, you get 25 feet the index. Now, notice those were every 5 feet. What if you wanted these to be every 2 feet, which were never drawn? Well, all this is doing is it's reading the data and it's generating where those contours would go, and as if you had done that as a 2D or as a 2-foot contour interval project before. So we'll leave it as a 5. And you, there's all kinds of things. You can highlight depression contours and set those up. For instance, put them on a different layer. See topo DEPR for depression. Let's see if I've got any particular one. D topo. See that depression doesn't exist. So it would make it for me. So we'll leave it at that. Text size, a 10th. Let's use a line type. Uh, Dashed 2. Well, so we gotta select it, right? Okay, there's dash 2. All right, and then we could turn on contour smoothing, which I'm not a big fan of because contour smoothing might make things look smooth and pretty, and that would be okay, but they're not really representative because technically when you're like right on a contour in one of those smoothed out areas, the actual surface elevation might be different from what the contour is indicating. So, and I generally, a lot of people use them to hide problems in surfaces, and I generally like to go back and fix the problem. All right, so in any case, I'm not turning any smoothing on. Um, and I'm going to next go to labels. So let's might as well label them. Let's turn our labels on. So we're going to go choose our layer again. I'm going to go again and look for C dash topo just for consistency. And there's a C topo label, LABL. So I'll use that layer. And I've got a label style of cont dash label, which I'll use. Now notice that style doesn't exist yet. It's going to make it for me. Okay. So I'm going to come up back to this label layer and I'm going to select it, right click and copy. And now for my index label layer, I'm going to select all of that and right click and paste because that, I don't care if it's index or intermediate. I want that because see, it's letting you make them on 2 different layers if you want, but I'm going to put them up both on the same. And my label text size scalar, remember that word scalar. If you ever see that, or if you see plotted text size or plot size, always think to yourself, plotted inches at whatever my drawing setup is. And I don't even know what this, I haven't checked it yet. So we'll see. See how big the numbers come in on our labeling. Now within this, I have some controls on what I want to do with it. I can set the text size, the minimum length. I can do, you know, positives and negatives. For instance, if this were a cut and fill surface, a surface data that consists of values that indicate the amount of cut or fill. So that would be positives and negatives. So you could put, negatives would be the cut value. So you could say uh, positive contour prefix, you might say that's an F dash, and then negative would be a C dash. Just all kinds of things you can control with the appearance of this. But this right here is the most common, these checkboxes, and we usually think of drawn contours with labels on them as if we have broken the contour around the label so it doesn't look like the label goes through the text. And that's one of the options right here. Break the contour label. Now, if you do that, it will physically break that line, that polyline. It draws it as a continuous polyline, but wherever the label gets placed, it then will go back and break the polyline and take that segment out, or you have the option to uh, also draw those broken segments and put them on a special layer, maybe that you could freeze. But if you ever needed the segments that it broke out, you still have them. You could go back and get them and put them back in place. Now, all that's well and good, but there's an easier way of doing that. If I uncheck that break contours at label, there's a corollary down here below that says hide the drawing under the labels. Well, that will have the appearance of having broken the contours, but it blocks the drawing underneath the label with what's called a wipeout. So you'll see the labels will have a little wipeout frame around them if frames are set to be on. And we can treat it as if the contour line has been broken. Now that's an important thing to understand. That is, if we do not physically break that line, if we just hide it like we're getting ready to do, then we have access to another really kind of nifty command that we'll look at next that will allow those labels to move along that line. Otherwise, if you break the line, it loses the ability to slide the label along the line to a different location. Okay. So we're going to hide, and we will label index contours only, because that's, I'm not, this is not such a flat area that I need those specific labels. Align the text with contour, and that typically means that it's going to rotate the text to be in line with the contour line segment that it sits in. Okay. There's another option there that you can draw where it says a line facing uphill. And that is a, uh, a technique of drawing contour labels that is not used very often today, and especially not really used. In fact, I've never seen it used on commercial products, but back in older days, when if you were in a particularly flat area, so that maybe an entire quad sheet of mapped area might only have 3 or 4 contours that cross it, and you have no idea if you're looking at a particular spot, you know, which way is uphill. I don't know, um, unless maybe you don't have but the one contour on there that's gotten labeled, so you don't know which way uphill is. You just know what that one elevation is. So if you have that on drawn that they face uphill, then you would look at the map and you would position yourself such that you are reading the label. Then if you looked up from the map, you would be looking uphill instead of downhill. All right, so it's just another little indicator. Again, I've never really seen it used, but that's what its intent was. All right, so we're going to align with the contour, and I'm going to draw on the real Z axis. So I'm going to put the label at its elevation. There's no real need to have to do that. It's just a preferential thing. I like them done that way myself. And then finally, there are the label intervals. And you can choose if you label the intervals, you can choose no internal labels, in which case it would only label out here on the ends of the contours, or 1, 2, 3, or 4 per contour. Well, that's not, necessarily all that good because it will try to force 4 contours onto a small circular contour and that would just obliterate it. So I'm going to go back to this distance interval. And now this distance, I'm going to set this to be, now I know this site is going to be, I don't know, let's say, let's say 250 feet. Every 250 feet, it's going to drop a label. And I'll say, okay. And off it goes. It reads the surface, and there it is. And there are my labels every 250 feet. Now I can see there's 150, there's 150. Now I told you that it was going to look like um, the contour was broken. And in this case, it comes up and it doesn't indicate that. For whatever reason, it's not. So if I select this and then select similar, so I've got them all selected. Now I'm going to right click and set my draw order, bring them to the front. And is that what's going on? Or let me see, maybe I'm in wireframe. The 2D. Yeah, okay. I needed to have been a 2D wireframe. That would have shown up correctly. All right, so there they are. There's my labels. I see they're sort of there, and 250 feet is a little too often, so maybe I want to redo that. Let me also look at my drawing setup. So settings, drawing setup, I'm at a 40 scale. So let's make that a 20 scale. I'm going to change that to 20. And now notice something else that's gone on here. I've got this LT scale is set to 1 to 25 because I said my line type scalar should be 1.25 inches, meaning every 1.25 inches of a given patterned line style is going to start the pattern over every 1.25 inches. So you've seen some maps that might be like a water line. You'll see a line and then a dash and then a W and then a dash and then a line again. And sometimes you'll see maps of where they're done where the W's are like every half inch or every quarter inch. They're just W, 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 and it just gets in the way. Other times you'll see them to be further spaced apart. So that's generally what I like to do is have them like every 1.25 inches on my map sheet. So that would be my line type scalar. However, this LT scale over here is computed by taking that number, my line type scalar, and multiplying it by my scale. Now, this is something, and I wish it wasn't set up this way, but this is the way AutoCAD handles patterned lines, and it doesn't do it all that efficiently. It doesn't do it, in my opinion, the correct way. But there's two different choices. You can constantly readjust and reset your line type scale, that LT scale value, to be whatever scale it needs to be to where when it draws a patterned line of, in which our case, our line type scalar field says 1.25, so that's 1.25 inches, or plot units rather, in which case would be inches for us. So every 1.25 inches to draw this, to repeat the symbol, well then it needs to set my global line type scale up to 25 to make that happen. However, if you do something like this. I'm going to change this to be, instead of 25, I'm going to go into this field and I'm going to directly set that to 1. I'm just going to make it a unit size. Now that says my line type scalar is 0.05, but that's not really what's going to go on, because when I finish this, I'm going to do another setting. So I've got this LT scale of 1. Say okay. And now notice, see that text got smaller? And if I do that again, let's set it to be 100 instead of 20. Set this to be 1. Say okay. Now you'll see the text got bigger. See? And yet the gap stayed behind. And that's because, now what's happening is because this text, if I select that text, let me do this. See, it's just selected. Let's get a group. I don't want the group, I want the text. There it is. So if I select that text, you see it says that it is annotative. Yes, indeed. And for whatever reason, its annotation scale is 1009. Did I set my, oh, you know why? Because I mistyped drawing setup. Yeah, instead of 1009, it's 100. I hit too many keys there. Let's say okay. All right, now, so if I select that now, and now you see how the text is bigger. The wipeout, which is behind it, making that little blank area in the line, did not rescale, only the text. And that's because when I select that group, pull this down, choose the text, it says that it is annotative. Yes, at this scale, then what's the paper height it needs to be? So that would be 0.08 inches. So there's that plot size scalar that we talked about in our defaults. And so it would, that would be the size that it needs to be at 100 scale to be 0.08 inches tall. Now, line types, if I zoom in, you see that line type, I think is, typical major, what is its line type? Major, it's all just continuous. All right, I'm going to set that to be, I'm actually going to load. Get this contour 2. I'll load those both up. And now this is the major. I want to be contour. And then C topo minor, I'll set that to be contour 2. Okay, so now there you can see the pattern. But when you're zoomed out right here, it doesn't look that appealing, does it? So I need to do a couple of things here. I'm going to select all of these lines, right click, select similar. I'm going to turn my line type generation on. So one of the things that's going to do is allow the pattern to go through the corners instead of every time it hits a vertex. See, every time it hits a vertex there, it restarts that pattern. All right, so I'm not going to do that. I'm going to make them general. So I just selected one of each. I right-clicked and chose select similar. And then over here where it said line type generation in my properties, I pulled that down and said yes. Okay. So that's one thing. We're setting the stage here. Now remember, we've got our drawing set up at 100 scale, but see that LT scale got automatically reset to 0.1. So I'm going to make sure that I set that to 1. So you have to constantly come back to this thing and reset it. So now do a regen, REA is to regen all. Now you see the dashes picked back up, but even at that, they're still kind of close. Now here's what I mean by that going through the corner. See there, the corner, the pattern just happened to be right there where I was able to restart. I'm going to see if I can find that corner. that lands in a gap. I think their scaling is so small that they're going to all. There's one. See, there's a corner here that if I zoom into it, you see the actual end point is out here slightly in that. So if I were to select this and change its line type generation to no, see how it restarts at that corner? But here's the other problem. If you get these where there's too many contours really close together, you'll get what looks like big chunks of straight line segments that are connected. Like here's one where you see those are connected across there, but the pattern won't flow with the same even distribution of those patterns. So that's why I set those line type generations to yes. Now you can also set that in your drawing template or set it before you do the command. And that's with a command called pline gen. And if we type that, it wants to know the new value. I'm going to turn it on. That means now anytime I draw a pattern polyline, it will set that to yes. So it's going to do it. Now, I've also got that polyline set to 1 or the pattern set to 1. And you see, but my dashes are just still real tiny. And I typed my LT scale and it's also set to 1. So that should be okay. But there's a command that has to be done in conjunction with that. And that's called MS LT scale. And that means in model space, do you want to see the effects of the line type scale on the lines, the pattern lines? Well, yes, I do. So I'm going to turn that on. And when you do that and then do a regen all, see how much bigger they look? And that's at that particular scale. If I were to change my scale under, let's make it a 50 scale instead of 100 scale. And when I set that to 50, that's going to apply that to the current. So I'm going to change this back up to 1. And now you see the dash sizes got smaller, as did the text. That's because they are annotative. They're changing in relation to the changing of the scale. And that annotation scale is also available down here on your status bar. All of these different particular ones. Okay. Now, that same corollary MSLT scale also goes along with PSLT scale. There's a for paper space. So you would set that on and off to have it react accordingly as well. All right. Now, there it was, or there it is at this particular scale. There's the size of the text, but the wipeout, you see, and if I turn on my wipeout F, I'm going to type wipeout F, which starts and finally finds the command wipeout frame. And if I hit enter, I'm going to change that value from 0 to 1. And you see, there's the wipeout that got created. And if I'm going to type it to be 0, it's going to hide the frame. So it's going to generate that as a wipeout. And if I were to select similar and put them on in the front, yeah, see that will, it just trims to the edges of that. Now, let's go back now and again because we had the very same thing that we did. Now there's your depression contour. Remember we told it to go on a different layer and use a different line style. Now there's an example of here's the right line style, but you see that it stays solid for this whole big long chunk because why was that? The line type generation says none. So I'm going to select that one, right click and select similar, and then change that line type generation from no to yes. So now the pattern flows freely. And even like you see the corner is out here, but it's not actually in part of the line work itself. All right. So we've got our mapping ability to create that from the surface. So let's go back now because I've changed my scale and I want to change that interval to instead of every 250 feet, let's make it every 750 maybe. There's 250, 500, yeah, every 750. So what would you do? There's a number of things you can do. You can select all this stuff and delete it, or you can edit, erase by layer, and then pick from the drawing and choose all of this stuff if you want as well. Or you can simply go back to, and the other thing, you could isolate the layers that have everything on that you want to erase, and then select everything on the screen, delete it. But if you go to surface, let's just repeat that command. Contour from the tin file. Now this time, we choose our file, there's our file. And when it comes up here under the triangulate tab at the top, I'm going to change my erase previous contour entities to all contour entities. So that will get rid of all of those items. Okay. I don't have to select them even. So it will then draw these. We got everything's good to go, setting up. The layers are all defined. But here, and again, there's my 0.08. So it's going to take care of that because I've changed my drawing scale. They'll be that size now. And I want to go down here for my distance interval every 750. I'll say okay. And off it goes. And there now you can see the density of the contour labels is more in terms of what I was expecting. Okay. Notice this line got generated with line type generation turned on because I did that command earlier, P line gen, and that's just a setting in AutoCAD. It has nothing to do with Carlson, and it's just whether it gets created or not. All right, so there it is. Now, what can you do once you've managed to plot your surface? Well, if you could, again, you can change the scale. Um, In fact, I think I'm going to anyway, just because when we design the road, I want it to be a little larger. I'm going to put that up to say 20 scale. Oops, let me try it one more time and also remember to put this at 1. And now 20 scale at 1. And I'm just going to redraw the surface so it creates them uh, surface contour from tin file. There we go. Contour from the tin file, so it's going to recreate that and all the gaps and everything that we have. And it's just going to be easier to just let it redo. So we'll go there, everything's fine. Make sure my labels are yeah, see, I changed scale so that bumped the scale up. So I'm going to say 750 at this point. Now say okay. And there now are those labels at 20 scale, but they're still only at every 750 feet. So for instance, in this shoreline, let's see, one label there, one label there, one label here. Now here gets back to one of the uh, probably should settle on a 50 scale just for context. But here's one of the reasons that we did when we did this surface contour from tin file under our settings right here for the labels, we said hide the drawing under the label instead of breaking it at the label. And the reason for that is so that we could do this. If you go to the surface menu and look for contour labels and go to the right, and you want to move the label along the contour. So when you do that, then let's zoom in and find a particular, well, those all look actually in a good spot. Oh, they're so tiny looking. All right, so let's say if that was in the way of something. So if I just now click that text, just grab it, and then you see as I'm just hovering the mouse. So if I move this around, it's going to walk around that contour. In fact, if I even move it all the way over to here, it will change its orientation. Once I let go of it, it repositions it there. And then just grab it again. See, it's letting you put everything around where you might want it. Okay. So just a nice little uh, tool to help you manage your data a little nicer. All right. So let me go one more time. I'm going to set back to a 50 scale. I don't generally like to do road plans at 50 scale. I generally like to do them at 20 scale, but this drawing is sort of goofy anyway. And that's because it came from Autodesk. It was part of their training curriculum. And I'll show you some of the concepts that oops, I meant to do that one more time. Let's see. Labels. Yeah, that's what I meant to do. Set that back to 750. There we go. All right, so there's your label. And if anything's ever in a raw spot, just use that command and it just walks along the label and orients itself correctly. Okay. So with that being said, let's save our drawing. We're going to take our lunch break. Um, and we're going to talk about, because not only do we have the ability to redraw these contours, but we also have a complete surface file that we can look at, modify, design against. Here's now if I go to my settings and turn off the contours, there you see that looks just like we saw it when we first opened up the file in their drawing. That we saw those little triangles. And so that's what Carlson's viewer is doing. There's the triangles turned off. Uh, they're going to be colored in because it's reading the surface, which consists of all of these triangles, which are treated like 3D faces. So it loads it up into our viewer. And here we have, you see, there's a little spot. It's either a spot of bad data or, somebody's little, um, see, it's truncated flat. So it's probably got some bad data in it, but c'est la vie, c'est la guerre. Now, one of the things too, and I'm changing this yellow light over here on the right-hand side, that's my light source, just to get some contrast going here. But you see all these little rounded cones, these things are just flat across the top. Well, that's because if you go back here, down here's a big one, you see, it's just flat across that top. So if I'm going to exit my viewer and I look at this, that's because this surface file was created by somebody who just looked at contours only and said, okay, when you hit that contour, there's no other data in between there. There's no spots that tell it that it goes up or down. A couple things that you can do to mitigate that is if you were building the surface. Now we're not, because the surface was included in our data file and we just converted it. But if we were tasked with having to build this from contours, you've got this switch under the surface menu, triangulate and contour. Okay, so if we were going to build this by reading the contour lines, one of the switches that we can control is on the triangulate tab down at the bottom. There's two categories. There is an adjustment for the source data of contours, and then there's another one below that, adjustments for dense existing ground source data. Well, this would be if our source data consists of contours, you could turn on to interpolate summits and pits. And if we were to do that, then that would, instead of stopping at that sawn off flat place, it keeps pushing it up. Now, to show you what I mean by that, I'm going to go back to triangulate here. I'm also going to minimize my flat triangles. I'm going to go back to triangulate, and I'm going to say erase previous contour entities. I'm going to turn that off because I want to keep the ones I've got. I'm not going to draw any contours, but I'm just, make sure there's nothing in selection. All right, I'm going to write this file. I'm going to call this one phase 6 mod for phase 6 modified, okay? And I'm going to say okay. And it wants me to select the points and break. Oops, I need to change that again. Repeat that. I need to tell it what. Sarah and Scott, if you recall. What do I have that I did not take advantage of? This inclusion boundary, right? So that way I can choose this boundary out here and that'll not allow it to form triangles out here in these open areas. So now I'm going to select that as my inclusion, no exclusion. And now select the points and objects to break line. We'll just take them all, hit enter, up we go. And notice there are a couple, well, more than a couple. See 7 feet, 4 feet. I know why that is. That's exactly because this is a 3D polyline instead of a 2D. So we'll try that again. We'll right click and let me see here. Repeat the recent command try seed colon try triangulate. So yeah, we'll do that. We'll still use this area, but instead of selecting it, I'm going to say yes, okay. I'll use it for the boundary. It says okay, no exclusions. And now, so again, I'm going to type all and hit enter, and it still lets me select one. So I'm going to type R to remove, and I'm going to remove that 3D polyline. Now there you go. I still got some things. What is it? Zoom to. Like 5 feet. There's a crossing. I don't see anything that's crossing there. I'm suspecting. I think I know what this is. No, I thought maybe it was going to be like these depression contours. Anyway, I'm not going to track that down to try to figure it out, but I do want to show you the difference in the surfaces. Because if I'm going to go to view, 3D view, surface file viewer, I'm going to select my phase 6 original. That's what I had before. And now I'm going to go over to the model tab at the right hand side. And I'm going to choose this button to add a surface. I'm going to add that phase 6 mod. So it's going to come in as its own surface. And then where I'm going to open up surfaces here, I will zoom this up and let's zoom down into these areas. So if I take the original, I'm just going to double click on it and turn it off. So you see this. Now let me turn that back on and turn this one off. No, this one off. So there's the original where we didn't have that switch on. Turn that one off now. Uh, Here's the effect of us telling it to, yes, interpolate those summits and pits. So it tries to push it up, you see, to where it's not so flat. So I'm not sure that it's necessarily doing a fabulous job with it, but you know, you can see the effects. So again, just something that I notice. Let me turn that on and that back off. That's just something that I notice after, you know, from years of working with this kind of data, how I can tell that something's been done. I look at that and it immediately tells me somebody built this from contours. Now, there may be a part of the world that's actually like that, that these are all sawed off flat pieces of hilltops. I doubt it, but you know, without knowing otherwise, you can't make the assumption. All right. So that brings us to a good stopping point for lunch. I'm going to save my drawing and we'll talk about um, a little more depth on this modeling surfaces and maybe get into some of those nuances. Okay. So I'm going to pause that recording. Um, so right here. My sincere apologies on that, folks. I'm really sorry. I've only done that twice. And you know, Sarah and Scott, you may have been in the class that it happened to the last time. I don't recall, but uh, so what I'll do is I'll send you not only the recordings from our sessions, but I'll also give you one from a previous civil class. No guarantee that it's going to be the same material, of course, but I mean, it will be generally the same. And so you can pick up on uh, some other information from those others as well. So I apologize for that. But anyway, we'll wrap that up. Now, what I want to look at next, and I was thinking about this over the break actually. I want to go into um, more of this, you know, using the 3D viewer and doing 3D grading and design work and terrain modeling and break line structures and all that kind of stuff. And I think that's going to be better suited if we do that in the morning and we pick up and we start looking at some grading examples as to where we will uh, wind up going, you know, to couple that together so we're not too disjointed in what we're doing. So what I want to look at now, just for the last 20 minutes or so we've got left for the day, is let's look at some of these other options in here that because we've generated some cross-section files, if you remember, on roads, process road design. And down here at the bottom, we chose this design section and existing section. So it created those two files. Okay, so now there's nothing in here that lets me edit those, but if I cancel that and let's go to the sections menu and let's edit our section files. Let's see, section file editor. It's right here, just the last of the second sections on the menu. So our section file editor, it wants to know the section file to process. So we're going to put in here first our section file for the finished grade, which is this Main Street FG. And so that loads up this. And if I look at, you know, any given one of these, there's my cross section for that particular section. I'm going to exit that back out of here. And but also you can do a reference section. So if we reference the existing grade as well, and you see that reference center line, it knew to pair that up with that. Now, if you just pick on one of these and edit um, the particular uh, section there, just double click it or choose edit. Now here's my, let's look at my vertical exaggeration. And that is at 1. Let's put it at least up to 2 so we can see a little bit here. And as you can see, as you click around in your spreadsheet, just like in the profile editor, it jumps to these different um, points along. See there now, and you see that point is named. See that there's buff. There's that buffer from the edge of that, from this from the curb out on the left-hand side. And then here's the curb points. And if you go down here past, there's the center. Um, so you can see, and then as you go along, there's the edge of pavement, center, then it's got the subgrades. So different points, and it tells you their slopes and depths and elevations and that sort of stuff, offsets. And then, as you see out here around on the sides, you can go all the way out here to, these points out here in the sidewalk. There's your tie. That's where it hits the ground. Now, this down here below, this lets you, scroll to any particular section. You can also, there's a button that says drive. And if you say drive, you can give it as a design speed. Let's give it a 35 mile an hour. Let's not auto zoom. Let's just look at, say, 75 feet either side. And we say, okay, and now, well, I guess we better, let me stop that. Yeah. I did say stop. All right, so let's center the section. 75 to 75. Let me center the section and auto zoom. There we go, maybe like that. What the heck? Well, stop apparently won't let you stop till it finishes anyway. Anyway, all that does is basically slides through all the sections that you've generated. And I think if we did that, there now it's something's out of whack. It's not stepping through. All right, let's take this back and cancel this. Let's look at let's look at 1500. And now if you drive full grid, 575, center of the section. Now there it is, except it still rides off the page. Well, in any case, probably don't focus, just leave it set to centered and you can see it shifting along its length. It should have looked like that. You can see, there's where it's perched up on that hilltop. So now, one of the things that this is also useful for, these section files, you can actually make edits to these points and, go over here and you find that point and change its elevation or its slope and all that kind of stuff. And you can actually, do that to modify your road design. But here's where I wanted to show you where this is. See, one thing too is, let's say if we've got, here's section 1500. And if we go to the next one at 1525, and you see right down here, my station values here are increasing. So 1500, 25, 50, 70, that's probably a PC point. And you can come over here and check a particular offset. You can look at a different, you can type in a specific section, let's say like 1535. Is not in our, see, it's not in our list, so it doesn't show us what that is. However, if we want to look at what 1535 is, that's between 1525, 1550, you can interpolate. So if you interpolate a single station at, say, 1535, what it's going to do is generate that. We'll call this one mod. Oh, sorry, existing. Profile, there's the profile. Okay, so now 1535. Reference profile. Station already, okay, so it created it. So now, oh, right there it is. So now it regenerated that at 1535. And you can see it doesn't have all of the, it's just using that top surface because that was that finished grade certified, but it interpolated that between the 25 and 50, and it just sort of it interpolated between those two stations to give you that station value right there. Okay, so that's a useful function for seeing some of those and maybe even making changes to it if you need. But here's, no, I'm not going to say the changes now. Here's what is useful in their road processing. If we go to our roads, process road design, and let's look at the design profile for a minute. Let's edit that. Now that you've seen before, and as you move along, you see where the things are in plan view. Let's move this over here and get a little closer. But I'm going to also come down here and say show sections, and I choose my design template. And I'm 1106. There's my 2-lane 12-foot with curbs. No transitions or any of that. I'll say okay. And now this is going to float, wherever it happens to be. And as I move this around, you see how the cross sections are showing. But also look at the titles up at the top of my profile editor. It shows me the cut and the fill at that given station, but it gives you the totals. And so there's a total cut of 51,000, total fill of 4,800. So if I were to then decide I need to move this up a little better, and bring it up just a wee bit there. Let's see, that's, now you can see my totals. I'm at 6,700 to cut, but 30,000 in fill. So maybe pull this guy back down a little bit in there. It's a little touchy. Let me set that. Oh, it doesn't give me a choice on the vertical exaggeration if I'm showing the sections. All right, so I could sort of tweak that. Now I'm at 31,000 of cut and 4,000 of fill. Something's not right. Let me see here a minute. Let's exit this. Show my sections. There's my design section. Total cut is 30. 1,000 yards in total fill. Well, that doesn't make sense. I save that and exit. And let it reprocess here a minute. All right, so I've got total cut. Yeah, 31,000 yards of cut and 4,000 yards of fill. If I look at that. Oh yeah, I see. I've got all this cut over here. You can't see this cut represented in the center line. It's only along the center line in that profile editor. That's why it didn't look so hot. But yeah, that's mostly cut. So then I would go back to that profile editor and you can play with that profile a bit. Since it's mostly cut, you might want to, uh, raise this curve up a little higher like that. Now you see if I show my sections. I don't know why that file name's not sticking. Now I'm only at 5,000 yards of cut, but I'm at 39,000. So it's going to be a happy medium in there somewhere. So let's see if we can find it about. Oh, it's not letting me till I turn this off, I guess. I'll show my sections, get my template. And now, well, I'm still back to that same old issue. We've got too much cut. So if I raise this guy up, well, way too much. So anyway, you can use that to sort of get a sense of, and if you just do it visually in trying to get the center line along the center of the existing road, you see how it's deceptive because I've got all that side distance information out there that you can see. If we show these offsets, show the existing grounds, let's go out 100 feet either side. And now you can see why you're in so much cut because of this stuff on the high side here. So that would let you maybe pull this guy up a bit and this guy up just a skosh and try to sort of even Steven all of those, then show the sections. Now I'm at 13.6 and 14.9. So that's about balanced within those limits. So that's, once those sections are there, how you can use them, once you've designed that template, it actually processes this. But see, I've now lost my low point, so I would no longer have to worry about putting a gutter point there because that's no longer a sag curve. It doesn't dip below where it starts. It's always on the upswing, even though it's a vertical curve that goes up instead of down. So if I say that and exit, let it process. Now you can see our total cut is 13.5, our total fill is 15.0. And you can see now when we look at the surface, you see it's a little bit better balanced, not quite so much heavy on the cut. And I've got this fill down on this low side here as well. Okay. So just a couple of ways to help you fine tune that in terms of a design spec. But again, if you're building this from somebody else's design, that's nothing you have to even really worry about. Okay, now one last little thing to talk about was this business down here on this road or this template point profile and center line. And I'm talking about what that's going to do. I'm going to I'm going to choose a layer here. I'm going to say, I'm going to make a new layer and I'm just going to call that TPL dash mod, template mod. And let's make it some color we'll recognize here and we'll make it, give it a little weight. And we'll set that current. And I'm just going to draw a 2D polyline on the current properties. Say, okay, and I'm going to come in here. Excuse me. And I'm just going to draw a line from here out to here. Come back to say in here, and then maybe bring it in like so. Okay. Now I'm going to trim that off at this edge of pavement here. So that's going to be my trim line. So select that. I'm going to trim this and this. And I'm going to just put a little fillet curve in here with a radius of whatever that happens to be, 5.9. Let's make it 10. Put a 10-foot radius there, and we'll repeat the command. We'll make this a 20-foot radius over here. Okay, and then I'm going to add the repeats. I'm going to repeat the draw 2D polyline. I'll say okay, and I'm going to come down here and just say continue, and I'll pick this line here, and I'm just going to continue up to right in here. I'll do the same thing down here. Repeat that command. Choose continue from this end. And I'm just going to come down to right there. All right, so now let's put some fillets in there. So I'm going to fillet with a radius of, let's just say a 5-foot right here. And repeat it, keep the same radius here to here. Oh, fillet radius of 5 feet. So this to this. There we go. So I've got some curves in there now. All right, so what this is going to be is I'm going to turn this into a center line. So I'll go to center line, polyline to center line file, and I'm going to call that my pullover. Select the polyline. There it is. It's now made that center line file. Now, if I go back to roads, process road design, I want to choose that template point center line, choose that button, and I'm going to choose, where's my file? Oh, wait a minute, I'm sorry. This is going to be a new TPC, and we're just going to call that one pull off. Be a different story, but now I need to edit that template point center line. I'm going to edit that by adding, first of all, I'm going to set my reference template. I'm going to set to my two lane 12-foot curbs. And I'm going to now add the ID I want to push out is going to be my edge of pavement. Okay. And I'm going to select my centerline file. There's my pullover centerline file. And which side to use? It's the left side of my alignment, so it's already set. And I'll say okay and save. And now say okay and process it, and you'll see what happens. So instead of me having to design a template for 12-foot lanes, when it builds this, you see what it did? Once it found that center line, it followed it along the edges and pushed the edge of pavement out there to it. And everything beyond the edge of pavement went with it. Okay. And it also included, putting that into the surface. So right there's the surface. And you see how the curb went around with the edge of pavement. Now, one of the things, let's see if I can get a shadow to show up here. If you can tell from this, it went from here's the crown of the road, and it goes down, curb, and comes up, sidewalk over. And so that pushed that out there, and it kept that at that same slope. It just went from what used to be the edge of pavement here and just pushed that on out at that same slope. That's when you only use the center, the center line, the template point center line. But you can also have that do something different. If I want to make a profile that goes along with that center line, let's do that. I'm going to go to my profiles tool and choose design road profile editor. I'll make a new one here called pull over or pull off, or no, pull over, doesn't matter. So it's going to be pull over profile. I'm going to use my pull over center line and use my phase 6 original ground. That's fine. I don't care, but there's the original ground. It's going to get up here and basically follow along that, but I don't really want that profile. No, let's see. I need a different reference. I need to find this elevation right here where it starts. Oh, I don't know how to do this better. Let's just repeat that road profile, use their pullover profile. We'll use the pullover center line. And now this time, instead of phase 6 original, I'm going to use that the road surface as the reference. There we go. So now at here, there's my depth. So I need to come up here to whatever that elevation is. And there, why is my reference? I'm still not. That should tie that. If I had 0 there, that should tie that up to that point. Let me try this one more time. If I edit, let's design, let's just use the profile editor. Pull over. And if I reference center line, my pullover center line, and reference the profile I've got Main Street EP left. That was from a long time ago. I did not generate that. Let me cancel and exit again back. You see what I'm trying to do is let's see, design road profile. Pull over. use that center line. And the surface I want to use, I want it to follow the Main Street Road surface. So that would be that existing surface. This is not. All right, so if I move here, that is not, there's 0, comes out to here, and it doesn't go, it goes out to here. Oh, I see. I don't know what that, oh, I know what that is. Sorry, that yellow line is that reference. There we go. That's better. Now it's lying right on that surface, and it happens to be exactly the same as that slope. So it's 0, 0. So if I add now a PVI here in the middle, let's just raise it up, and we'll give that a vertical curve distance of, let's say, 100 feet. See if that'll work. There we go. And do I show the reference surface? Now, that's what happened. So now it's going to come in here, and let's add another one right here. Oh, 40 feet. Let's see. Let's change this distance here to just 50 feet. And let's add one right in here of, say, 35 feet. And we'll do another one right here at 35 feet. All right, so now it's going to follow the ground, get up here and raise up in the high part, and then come back down like this to tie back down. All right, we'll save that, exit that. Now back to our roads, process road design, and our template point profile. So we're going to call this one our pull off. And now we have to edit that to tell it what to use. So we're going to edit, we're going to set a reference template, which was our lane. We're going to add the ID, this time also been the edge of pavement. We will select the profile file, which is our pullover, and it's going to be on the left, and we'll say, okay, and we'll save that, and then we'll process that. And now, once this happens, you're going to see how these contours in here, as it crosses this pullover, are going to reflect that rise in that, as it followed that profile. It should. And let's see if we can see it here in our no, it doesn't look too much like it. Oh, there it is. Yeah, you can see that it's raised up a little bit. Let me let's do a quick profile, and let's look at the surfaces. We're going to look first at that original ground, and then at the road. And I'm just going to draw a line across here. And so now, as I move along down here, you see where I am. I'm going across the road. I hit over there and then come down. Now, if I move that, I'm going to adjust the alignment. And I'm going to pick up near here, and I'm just going to move this like this. And you should see how it widened out. No, it still did not raise that profile up. Huh. Let's look at that template point profile and say this edge of pavement pull over profile, station reference, maybe that side to use is left, hold the offset or hold the cross slope. Let me try hold offset first. We'll save. Say, okay, let it process, and now we should see these change if it's going to let that ride up and over. There we go. Now, when we look at our road surface, yeah, you see the difference. You see it pushed that out, and it not only followed the alignment of it, but it it also raised it up to that point. And I said, hold the offset. So it went from that existing edge of pavement or the current edge of pavement back here and then pushed it out here to that high spot here. So that raised that up. So that's just a way that you can adjust these. And a lot of times when you're doing pullovers like that, you would normally not use a profile. You're just going to let it push that lane width out there and stop at that particular, just push that cross slope on out to that location. Okay, so that's another bit of that adjustment. And if you, let's see, one last bit on that template point profile. If we, instead of holding the offset, that's the original offset, we're going to hold the cross slope. Say hold the offset, adjust the slope ID, that edge of pavement. Yeah, see, I don't want that to adjust from the center line. I really only want it to adjust from the 12 foot over would be what I would like to have done. So if I hold the cross slope, I don't think, I'm not sure what that will do. Let's take a look. Whoa, that's pretty intense. Obviously not our intent, but it sure built it. Wow. So it held the 12%, or it held up to that profile that I did, but it lost adherence to the center line. So as they say, let that be a lesson to you. So we want to hold the offset, adjust slope ID. I think that's going to have the effect of not using the profile information. Let's see. No, it did the same thing, but it still pushed it from the center line over and not from the original edge of pavement over. So the best way to accomplish that would probably be to use a grade table. So we could tell it to go 12 feet out at -2% and then target up there to that particular grade. But we need to know what that cross slope is. So in practicality for a pullover, for instance, I would typically go to this template point CD and just hit cancel so that I take, or I'm sorry, not the center line, but cancel on the profile and have it use the center line only. Let's see if we had any processing options in there. We adjust the next outside grade distance. skip travel lane for parallel grades. All right, if we adjust the next outside distance, that might hold the edge of pavement and then push the curb only out. Let's see what that looks like. No, I think it's wound up being, yeah, it just turns it off basically. It held that with that adjust next outside. So the final bit is let's put that back and uncheck that. Skip grade when center line's missing. If we skip travel lane for parallel grades. No, that still pushes that down. Adjust the next outside grade. Skip travel lane. Don't skip the travel lane. Just the next outside grade distance. Maybe what does this do? Adjust? Yes. Skip missing? No. Skip travel. Let's see if that gets us where we're looking for. No, see, that's still going to, yeah, it's still going to turn it off. Don't adjust the next outside. Leave it at that, and that then should, now, so that's going to go from the crown of the road up to meet that. Well, right now there's no profile there, so I took the profile off, remember? So that was another thing that was possibly missing. So that's now put everything back and push this out at this 2% grade, okay? Let's see, there was one other last little thing. So that's that template point center line. Was I thinking of profile, follow the center line. There's one thing I wanted to, oh, I know what it was. So I pushed over the edge of pavement. So you see that pavement went all the way out here and followed there, and there's your, um, whatever that was, the sidewalk. There's the buffer. And then out here's these, that's that fill bench. But right in here, you can see the sidewalk. So that's there, or there's the curb rather. There was no sidewalk. The sidewalk was on this side. Okay, let's, I'm going to do this for a minute. I'm going to select this line. And I'm going to mirror that from here across that. Delete the original, yes. All right, so now it's tied back there on that side. That's now my center line over there. If I double click it, you should see the center line editor shows it in that fashion. All right, so now when I go back and process this, process road design, my center template point center line, I need to tell it to use the right edge, the right side this time. And now you'll see that same phenomena here is going to happen over here. And so there it is, including the sidewalk that got pushed out with it. You see the sidewalk right in here. And in our surface viewer, you can see how the sidewalk comes around with it. So this sidewalk just walks around there. Now it gets a little bit wonky right in here because of this sharp transition. It didn't have enough template drop resolution to pick up in there. So to get around that, if we looked at this process instead of these 25-foot station intervals, let's put it down to say 10 feet and see if that picks up more of it for us. Because we should pick up the changes. The transition shouldn't be so abrupt. Yeah, it's still got a little bit of trouble making that turn. But here's the other part that I wanted to show you that. So now I pushed that edge of pavement out there and the sidewalk and everything went with it. But you can, instead of say the edge of pavement, if we go to that template point center line and edit, I'm sorry, and edit that file. And instead of using the edge of pavement, let's push out. I don't know if curb will work. We may have to do the other one here a minute. Let's see. Let's try this and see. Yeah, so it didn't find the reference to the center line, so no problem. We'll not use the curb. Let's, in fact, I know what happened. If I edit that, and instead of a curb, I need to use curb right, because that's the curb on the right-hand side. Still not finding the center line reference to the curb because it's a structure. Okay. So instead of pushing the curb, let's keep the curb up where it was. And let's just push the buffer. So that's the point outside the curb. Now that should work. Okay, now you see what it's done is it's kept the curb out here, but it pushed the sidewalk out with it. And if we look at that, you can see right in here, let me see if I can get this up. There you go. You see the curb stays at the lane, but then it pushed the sidewalk area out. So you've got a little, maybe you're along a street in the center line and you're putting in tree boxes. All right. So your sidewalks are going to follow the road and then it's going to make a little circular path around the tree boxes, so you can use that technique to do that kind of adjustment without having to make these separate templates that show this widened area and then do a template transition. You just do it with those template point, centerline template point profiles. It's also a way that you can design special ditches if you need a ditch to follow along and it's following the grade, but then maybe it needs to scoot out here a little ways and come down to different elevation until you come back in. So a lot of ways that you can adjust those things in this road design stuff. Okay. So with that, let's save our work and we'll pick up tomorrow. We're going to talk about surfaces and then we'll come back and look at road network real quickly to just expand on the road part. And then we're going to look at some grading and tying everything in together and how we do a little side road that is going to come off of this and grade into, say, a parking lot with a building. Okay, we'll look at those tomorrow. Any questions to this point? Everybody good? So, and by the way, Patrick, you will get the extra credit for the half hour we spent today longer than scheduled in your PDHs. And now, Sarah, are you or Scott either one PEs or PLS? I'm sorry, are you or Scott either one a PE or a PLS?
I'm an EIT on my way to be.
You're the EIT, that's right. So if you had the direction, I'll just let you know that you will get credit for the extra time as far as the PDHs go. So for that, and everybody will get credit for it. It's just you don't necessarily need them like Patrick does for his registration. So we'll take that on tomorrow, and you can see, um, we got a little bit of a step going right in here, and that's because that ended at a particular non-interval like that. The template drop happened back there, and then it happened out here somewhere else, so it's a little abrupt. I'm gonna let you do that. So I'll put that back. I'm just going to come back here and clear out that file. Let it reprocess, and that'll take that pullover completely out. And now at this point, this is just a straight line. I can just get rid of it. The centerline file still exists. I will also set this back up to 25 so it doesn't take quite so much processing time. There we go. Now we're back to our simple state. I'll save that and we'll pick that up tomorrow morning. I will send everybody, just watch your emails. I'll send you the link to tomorrow's session. It'll be a new link. So we'll do that. When we come back tomorrow, I'm going to just erase these little polyline segments. And it's because of this weird surface modeling that they did. There's just a couple of little gotchas. Down there's that little raised area. Over here's the depression area. There's a depression area right in here too. Okay. I think we should be good to go. I don't see any more of those little connectors between hilltops. All righty. So with that, we will reconvene tomorrow morning, 9 o'clock Eastern. Okay. Everybody have a great night. We'll see you in the morning.
See you tomorrow.
Okay.